Welcome to the Caladium Exhibit Senior Design 2 poster. This presentation will detail the problem overview, the features of our unique design solution, and plans for the short remainder of the semester.
For our objectives and requirements, we had to create a standalone exhibit that clearly demonstrated the physics principle that gravity works on projectiles equally regardless of horizontal force. It needs to be fun and interactive for visitors to use, and durable enough to withstand 3 years of use by thousands of visitors each year. It needs to be functional and safe to operate by audiences of all capabilities and adhere to specific ADA and OSHA requirements. It needs to fit inside of a 13-foot by 4-foot space with an interaction height of 4 feet. It should not weigh more than 150 pounds per square foot and fit into an elevator at the new location. It must clearly demonstrate the moment of impact of the two projectiles. As for safety, there is a door on the left side to allow access into the exhibit with a magnetic sensor that will cut power to the exhibit when the door is opened. Calculations were done to ensure no slipping or tipping will occur. Extensive testing has been done with the prototype to ensure the exhibit is kid-proof, and the projectiles are a soft rubber and will not cause injury.
Here you can see an image of our final overall assembly. The user experience begins by a participant collecting 2 balls from the collection bin and loading them into the exhibit via loading tube. From here, the participant can press the left button to activate the loader and the balls are loaded into the dropper and launcher. The participant can adjust the power using the middle knob to launch the projectiles at various powers. Once the desired power has been set, the participant presses the right button and the balls are launched. This process is recorded by a slow motion camera and displayed on a monitor to be watched in slow motion.
The launcher and dropper assembly feature solenoid controls allowing for precise tuning of the system with repeatable results. The launcher assembly features 2 interposed motors topped with neoprene rollers to aid in gripping and launching of the ball.
To create a better visual for the exhibit, a Raspberry Pi and HQ camera module is used. This will record video at 90 frames per second and then replay the video at 30 frames per second. This will then be displayed on the monitor next to the buttons. An added feature is that the users will be able to replay the video using a trackpad connected to the Raspberry Pi and monitor.
The remainder of the semester will consist of the final phases of testing and verification for each subsystem. Once complete, the team will write instructional material which will be given to staff upon delivery of the exhibit. The exhibit will be delivered and the staff trained during the week of December 13th, allowing the exhibit to be open to the public by Christmas 2021.